I really would definitely want to dive further into sort of platform engineering for AI. And yeah, when I read your blog post and this kind of central MCP server, I think that's a big one, and it just is really an interest. I know there are people in San Francisco who set up booths and they have MCP versus CLI, and I think this one, especially for understanding how enterprises can share these APIs and build their agents, this is a super cool evangelist for the MCP thing. So yeah, I'd love to just ask further about that central MCP server.
This is around context engineering that we are also improving every day, and it's basically, this is the case probably in every big organization. You have a lot of internal databases, you have a lot of internal APIs to fetch certain data, obviously allowing them to an agent, to a large language model, goes through an MCP. So we already had an essential MCP for Python, for Java, and in time it really grew into many tools. And those are basically, it can be also external tools. It can be also Google Maps. It can be also Google, like weather API. So depending on the use case, depending on the agent scope, people can bring tools, contribute to this central MCP with different functions, and eventually it is enabled and it is served in production. We don't restrict. We try to basically enable all possible tools and database calls or API integration, which eventually leads to more capabilities provided to the agents.
Yeah, it's so cool. I think it makes me think of like a whole new way to have like connection between your sort of internal enterprise tools. Like you'd have like Slack talking to Glean and like that kind of story, but then also the way that you can also build like production use cases off of that MCP server.
Yeah, I think also later we probably even started with our centralized MCP even before we had all these MCPs provided by other vendors. Like Atlassian has one for Jira tickets, Slack has one, GitLab has one, but I think those come late. Those came later, even when we had the centralized MCP. We are now also able to integrate those into agents, of course.
Yeah, and then talking about the like back to the design of the partner guest messaging, I love how you have the sort of template retrieval that's like a Weaviate MCP, but then you also have the GraphQL API for the property details, and just I
Correct.
just love that example of like how you've like grabbed these two tools as like two MCPs.
Yeah, indeed. Because depending on the query, it might need to fetch an already templated response based on similarity. This is where we use the vector space. But it can be also a question about the property, and we already know how to fetch property details, and it's based on a GraphQL query. So this is a tool calling agent indeed, and it decides which tool to call given the query.
Yeah, I used to be kind of skeptical on the tool calling agents in favor of the sort of like defining some sort of like inference path. But I think Claude Code has definitely got me thinking that function calling agents are just here to stay. And yeah, and the sort of tools are the key. Yeah. I guess one other thing is I think the internal LLM gateway that you use is very interesting. How that does things like detecting prompt injection. I think that's maybe like another interesting aspect of the sort of like platform engineering for AI. Yeah.
Yeah. Obviously, one of the biggest problem in large organizations is that this like fragmentation. Different teams use different providers, different SDKs, different logging standards. So this GenAI gateway basically helps to standardize that. It becomes like a control plane for all GenAI entry points or the GenAI adoption inside the company. We provide PII reduction. We provide guard-layer services to either reject the query if it's not allowed, or disables prompt injection, or like can have intent detection, etc. So those capabilities come with the GenAI gateway if they want to use it. Also, the logging, the traceability. One important aspect when it comes to using LLMs is cost tracking, and it can be extreme. It can go to thousands of euros, even a day of run. And don't forget, we are a large organization. We operate on a huge scale. We're talking about million active users per day, million partners. So basically, any kind of experiment at booking scale can cost thousands of euros. And it's very important to track the cost as well. So when any team makes the LLM call through our gateway, we also track the cost. We also trace everything in our logging systems. And this gives great visibility. And it's important to make it so easy to use for teams so that they don't need to go create their own LLM call. Like you can't just give 1,000 API keys to teams within the organization and hope for the best. We basically enable all these different models providers through these gateways, where we also keep track on the users, the usage, the cost, etc.
Yeah, that's a super cool one. I feel like that topic itself, we could zoom into that one quite a bit, but yeah, I guess maybe before kind of coming back to Weaviate and Weaviate's component of the platform engine, I guess just maybe, yeah, we've talked about the gateway, we've talked about the MCP servers, and maybe just curious if you have any other like quick takes on the experience of platform engineering for AI and just anything of that nature.
Maybe one thing I can share about is, when it comes to choosing a vector database, we didn't just trust the generic benchmarks. When it comes to actually adopting any tool, any vendor, we like to do experiments. We like to do evaluation, and every company has different scale, different needs. So so Weaviate is a good example, and how we actually picked Weaviate is also actually the mindset that we have as a platform engineers, meaning that we basically look at the options, run some experiments, evaluate them for different metrics, and then eventually decide. So that's also how it happens with Weaviate. As I said, we didn't just trust the generic benchmark, because the question is not whether we could do vector search. The question is whether we could do vector search in a predictable way, cost efficiency, low latency with this scale.